Hello everyone, myself Sri Vidya. I am currently undergoing internship with InfoPillar Solutions on machine learning. Today I am going to take you through on task number 4, that is to perform machine learning model to predict the factors driving the prices of house projects in Boston. The expense of the house varies according to various factors like crime rate, number of rooms, etc. The data set provided contains information collected by US Census Service concerning houses in the area of Boston, Mass. The data set is small in size with only 506 cases. It has two prototypes. First is price. The median value of a home is to be predicted, and the second is NOx, which indicates the level of pollution. Here, our business goal is to predict the house prices first. There are 14 attributes in the data set like per capita crime rate by town, proportion of residential lands, proportion of non-retail business, NOx, nitrogen oxide concentration, average number of rooms, distance between employment centers, taxes, pupil-teacher ratio, black people ratio, and lower status of population, etc. We have to start with importing. I have used Python and Jupyter Notebook to perform this EDA. All are numeric data type and has no null values. We can change midweek column name to the name price, and also the column unnamed has no relation, hence it can be dropped from analysis. This heat map below confirms the same again. This table shows most correlated features with the target price. Below are the visualization graphs of all 14 attributes. Per capita crime rate by town is almost zero most of the times. It seems there is less crime happens everywhere. Proportion of residential land zone for lots over 25,000 square feet is zero most of the times. Proportion of non-retail business acres per town 5 to 8 and 18 mostly. Track does not bounce river because it's zero mostly. Nitrogen oxide concentration is 0.5 and 0.6 parts per 10 million mostly. So the air is pollution free mostly. Average number of rooms per dwelling is 6 to 7 mostly. Proportion of owner-occupied units built prior to 1940 is 90 to 100 mostly. Weighted distance to 5 Boston employment centers is 2 to 3 kilometers mostly. Index of accessibility to radial highways is 5 and 24 mostly. Full value property tax rate per $10,000 is 300 and 700. Pupil teacher ratio by town is 21 mostly. It is the proportion of blacks by town and it is for 400 mostly. It is the lower status of the population percentage. It's in the range of 5 to 15. Median value of owner-occupied homes is $20,000 to $25,000. Box plot here shows the median value for all the variables. Pair plot shows that price of the house increases when the room number increases, and price of the house increases when track does not bounce a river, age, and lower status of the population increases. Price of the house has no much impact when pupil-teacher ratio, black people ratio, and crime rate ratio increases. This is histogram analysis of all the attributes. The proportion of non-retail business acres per town is nearly 18 most of the times. Index of accessibility to radial highways is 4, 5 and 24 most of the times. Full value property tax per $10,000 is 666 most of the times. Pupil teacher ratio by town is 20.2 most of the times. Now, moving on to data pre-processing and feature engineering. The most negatively correlated with the target column price is LSTAT column, and the most positively correlated with the target is room column. Hence, if a room average number of rooms per dwelling increases, then the price of the house will also increase. If LSTAT, that is percentage of a lower status of the population increases, then price of the house will also get decreased. This is visual correlation heat map. In some columns, there is much difference between 75th percentile and the maximum value. Here we can evidence skewness with the data. Correlation summary shows most positively and negatively correlated column with the target column. Outliers present in crime rate, ZN and RM, that is rooms, and the distance variables. All columns except indus, room, chas columns are having skewness. Without skewness, actually should be in the range of minus 0.5 to plus 0.5 value. By using the distribution, we can see the skewness here. Next step is to remove the outliers, and the new data set is derived now. Data loss percentage is very less. Skewness removal and scaling is the next step. This is done to achieve better performance with the model. Models are implemented with tuning of hyperparameters. Linear regression is done with hyperparameter tuning, and we got the accuracy of 69%. For lasso regression, we got the accuracy of 69%. For random forest regression is done next, and we got the accuracy 69.5%. Ridge regression shows the accuracy of 70.7%. Likewise, we did decision tree regressor, gradient boosting regressor, support vector regressor, and at the last elastic net regressor. Table shows all the models done and with their scores. And this is the output which has original and the predicted price. Out of above model evaluation, a ridge regression model supports well for this analysis. Ridge and Lasso both are regularization algorithms. They are used when your plain linear regression model is overfitting. The advantage of a ridge is that it doesn't make the coefficient of any feature zero, because to reduce overfitting, a ridge tries to penalize the coefficients of the data sets, and which is called the shrinkage term. Alpha is the hyperparameter that allows us to decide how much it should be penalized. Intercept is the term which gives our output variable a value when all the independent variable turns 0. If you set fit intercept is equal to false, then your best fit line will always pass through the origin. So make sure it always be true. Normalize is used when you have not scaled your dataset. Toll tells you up to which decimal you want your results. 0.001 toll means you will get your output value only in 3 decimals. It is used to analyze any data that suffers from multicollinearity. When the issue occurs, least squares are unbiased and variances are large. This results in predicted values to be far away from the actual values. Hence, it performs L2 regularization to overcome this. This is our best fit model, so we save this model for our analysis. Key findings. Price of the Boston area houses mainly depends on factors like rooms, lower status of population, zone, black people, pupil-teacher ratio, etc. And crime rate is always low everywhere. Moving to the next task in this project is prediction of NOx level in Boston. To start with, we have a below pair plot comparing the NOx level to other data attributes, and it is the outcome. NOx rate increases on below factors if proportion of non-retail business acres per town increases and track bounds river, that is CHAS, and the lower status of the population increases. NOx high is in range 0.538 most of the times. NOx rate decreases if weighted distance to 5 Boston Employment Center and if building price increases. Next is the correlation heat map. Positive correlation exists between Indus building age with NOx and negative correlation exists between distance between employment centers residential lands with NOx. NOx, that is NOx increases when Indus increases and NOx decreases when Indus and dis increases. This is same visual correlation as we said above. Next is to continue with identifying and removing the outliers and proceed with the clean data set. Skewness removal and scaling has to be done prior to initiating the model. Here we used varies regression model to predict the most accurate model. For linear regression, we got the accuracy of around 83. For lasso regression, we got the accuracy of around 83.24. For random forest regression, we got the accuracy of 83% and so on. Out of these regression models, out of all the models, Lasso regression model seems to be the best suit model to predict the NOx level workstream. Ridge and Lasso are used for same purpose to reduce overfitting. The only difference is Lasso has a different regularization term which is called L1. It is simply the mod of sum of all the coefficients. So Lasso basically as opposed to Ridge can reduce the coefficients directly to 0. That is the coefficients of the features that are not important for predictions. And it has the same hyperparameters alpha, fit intercept, normalize and tau or random state as we used to Ridge previously. Here is the output. It shows original NOx level and this is our predicted NOx level. The advantage of using LAS, it's for feature selection. It controls the strength of shrinkage and variable selection, which can improve both prediction accuracy and interpretability. This is the best model, so we save this model for this analysis. Key insights. More NOx level, more the pollution. NOx level depends on factors mainly like proportion of non-retail business acres, age, proportion of residential lands, and weighted distance to Boston employment centers. That's all. Thanks for the opportunity.